Today we're going to look at graphing simple rational functions. So, you need to be able to describe transformations of rational functions. That's helpful to know shifts and stretches and shrinks, not so much reflections. But transformations you need to know because that's going to be essential to graphing. You need to graph rational functions. State the domain, range, and horizontal asymptotes. Okay, so it's all about graphing rational functions today. So, a rational function is a function that's made up of two polynomials divided. Okay, so remember, a polynomial has to have a, can only have non-negative integer exponents. So, like x to the fourth, x cubed, x to the squared, things like that. Okay, so the two polynomials divided. Now, the most simple one that we're going to look at is 1 over x. This is the parent function. The most basic rational function, 1 over x. Right? These are generally, not all the time, are going to have a vertical asymptote and a horizontal asymptote. And now, sometimes when we get to pre-calc next year, this is where the step up to pre-calc would be. We'll look at functions that have, instead of vertical asymptotes, they might have vertical asymptote in a hole. Instead of horizontal asymptote, it might have what's called slant asymptote, or some other end behavior asymptote. Okay, but for now we're doing pretty basic ones. So 1 over x. So the vertical asymptote. Find the vertical asymptote. What you're going to do is you set the denominator equal to 0. And solve. Okay, now, like I said, the ones we're going to do, they're going to be pretty simple. That would be, there'll be vertical asymptotes. The more complicated ones, you have to determine is it a vertical asymptote, is it a whole different things. But for right now, that's what we're doing. We're finding what are called the discontinuities. So what do you think that word means, discontinuity? Okay, kind of been taken out, right? If something's discontinued, that means what? No longer exists, or no longer is in production, or whatever. Okay, so what we're going to do is we're going to find the value that will not exist. Value of x that does not exist, the discontinuity. All right, a horizontal asymptote. Now, there's two different ways to find this one, depending upon which form the function's in. So we're going to look at it. There's two different ways. Depends upon which form the function's in. So I keep, there's no, always do this to find horizontal asymptote. Okay, so we'll look at each of the two forms and see, okay, how do I find horizontal asymptote in this form versus this form? Okay, so now remember, so vertical asymptote, we had those when we talked about log function, right? The vertical asymptote. Okay. Horizontal asymptote, we had them when we talked about exponentials. Okay. In both cases, the asymptote is the line that what? What happened in both those cases with the asymptote? Yeah, it doesn't cross it. It's going to approach, but never touch. Okay? Now, a vertical asymptote you can never cross. A horizontal asymptote, some of the more complicated functions you can cross, they will cross a horizontal asymptote, but then they'll come back and go along it out at the ends. Okay? For the ones we're going to do right now, they're not going to cross, but you can cross a horizontal asymptote depending upon the function. Okay? So this is the parent function. So it's got a vertical asymptote at x equals 0. It's got a horizontal asymptote at y equals 0. So that's the parent function. It's like this. Alright, so let's look at the first form. So the first form is y equals a over x minus h plus k. So now in this case, there's a couple different ways to do it, but this is where all the transformations come from when they're in this form. Okay, well remember, hopefully you remember that form. What is that? Vertex form of a quadratic. So let's talk about the transformations of this one. This is the one we've done in the past. Okay? What do they do? Vertical, not necessarily the slope per se, if it's linear, but A does what? Vertical stretch or shrink. Okay, and if it's negative, what's going to happen? It's going to reflect. Okay, what about H? What does H do? Shifts left to right. What's K do? Shifts up or down. Same thing here. A does the same thing. Vertical stretch or shrink, reflects if it's negative. H does the same thing. Shifts left to right. K does the same thing. Shifts up and down. Okay. The only difference is the inside of the function. Okay, the inside is in with x. This is inside the square. So the minus h is in with the x, inside the square. This is in the denominator, where the x is. The x is in the denominator. So the h is added or subtracted inside the denominator, in the denominator. Okay? Then the k is added outside. Alright? So same transformations occur. Just like when we did exponentials, it was the same thing. Log, same thing. It's the same thing, depending upon what the function, what kind of function it is. Okay? So draw the asymptotes, x equals h. So that's where what? If it's x minus h, set the bottom equal to 0 and solve. Well, if x minus h equals 0, how do I solve for x? At h. Equals h. Okay? This is the vertical asymptote, when the bottom is equal to, the denominator is equal to 0. Okay? X equals k. So now, this is a shift left to right, so let's think about that. So vertical asymptote is up and down. The only time I can shift the vertical line is if I go which way? Left to right. So my vertical asymptote is going to change based off my left to right shifts. Horizontal asymptote. Okay, it's horizontal line. So what's the only way I can change that horizontal line if I shift what? Up and down. So the shift up and down is going to change my horizontal asymptote. Okay? So, first thing we need to do is find and draw the vertical and horizontal asymptotes. Okay, the second thing, we're going to plot the points to the left and to the right of the vertical asymptote. So this is how we make our table, just like we did when we did the vertex. So we put the vertex in the middle, pick a couple points to the left, a couple points to the right. We're going to do the same thing, but now instead of using the vertex, we're going to use the vertical asymptote in our table. Okay? Then we graph, making sure we definitely don't cross vertical asymptotes, and most likely we will not cross a horizontal in this case. Like I said, we're doing the fairly basic ones right now. Okay? I'd say it can't happen. Most of the ones we're going to look at won't. Okay, and then if a is negative, well, if a is negative, so the parent function, remember the parent function from the first page? So it looks like what? Parent function looks like this, right? So if a was negative, what would it look like? If I were to reflect that, what would it look like?
It would be in the same quadrant.
In the same quadrants, it would be in a quadrant across from it, right? So this one that's in the bottom left flips up to the top left. The one that was in the top right goes to the top. So if A is negative, it's going to have that kind of general pattern to it. Now, it could be shifted down left, right, but that's what's going to happen. Okay? like I said, x minus h, you look at that on your vertical or horizontal shift, left to right. The k tells me my vertical shift. Okay? What questions do we have on that? Alright, let's look at how we graph them. So what did we say? Let's recap real quick. First thing to graph is what? What we gotta do? Find your asymptotes, vertical and horizontal. Vertical asymptote occurs when? How do I find the vertical asymptote? Denominator. So when is the denominator equal to 0? So if the denominator equal to 0, so I would do what? Subtract 3. So it would be at what? X equals -3. So x equals -3. Graph that. That's a vertical asymptote, so vertical line. Okay. Horizontal asymptote. How do I find my horizontal asymptote? Y equals -4. Right, y equals k. -4. Okay, because the -4 tells me I shifted down. Now, let's say if there was nothing there, if this was just that, where would it be? It'd be at 0, right? We start at 0 unless we shift. Okay, this one shifted down 4, so now it's at y equals -4. So I go 1, 2, 3, -4, so there's -4. Drawing my horizontal asymptote. Okay? So I got my vertical asymptote, my horizontal asymptote. Now we need to plot the points left and right of the vertical asymptote. So what I do when I go to make my table, so where's my vertical asymptote at? -3. So put -3 right in the middle. Now, what is the y value at -3? Remember, we said that is a discontinuity. So it's not existent. It does not exist. Discontinued. It's gone. Bye. Okay? It's undefined. The vertical asymptote, we never cross it. It never gets there. There is no value at -3. Now, do we understand why? Okay, never touch that line. Good. Why? What about that function makes -3 a no-no? Look at the original function. If x was -3, what would happen? What would happen if x was -3?
Divide by 0.
Yeah, you get 0 on bottom. Can I divide by 0? No, it's bad. No. Give me 2 over 0. It does not exist. You cannot divide by 0. Okay, so that's why I put that. It doesn't actually exist. That's undefined. So now I need a couple points to the left and a couple points to the right of that. So what's to the left of that? -4, -5. What's to the right of that? 2 and -1. So now we got to plug those in. Okay. We're going to talk about how to do it on a calculator in a sec. Make sure when you do it though, this is going to end up being what? So if I were to plug in -5, I would have 2 over negative 5 plus 3 minus 4. So if I didn't have a calculator and I had to evaluate that, this would be what? 2 over negative 2 minus 4. So what's 2 over negative 2? Negative 1. Negative 1 minus 4 is negative 5. Alright, if you have a calculator, here's how you plug it in. So you need to make sure if there's more than one thing in the numerator or the denominator, you use parentheses. Well, in the numerator up here, how many terms do I have? 1. So I don't necessarily need to worry about it. So it's just going to be 2 divided by. How many terms do I have in the denominator? 2. So I need parentheses. So we do parentheses x, but instead of x, I'm going to plug in what? Negative 4. Okay? Plus 3. That's the last thing in the bottom, so I got to end that parenthesis. And then I have to what? Subtract 4. So that's how I enter that in the calculator. So I'd have what? That'd be negative 1. 2 divided by negative 1 is negative 2. Negative 2 minus 4 is negative 6. Okay? So you have to plug them in the calculator. So, I got to plot my points now. So at negative 5, my y value is negative 5, and x is negative 5. So, negative 5, negative 5. So that's right there. I got to plot negative 4, negative 6. That's one back, down, so negative 4, negative 6 is there. So now, I can go ahead and sketch that part of the graph if I want to. I have to use these asymptotes as guides. Okay, the vertical asymptote I can never cross. So this part of it, I'm going to go down and I'm going to what? Go right along there, never touch it. Now, like I said, this is a simple one, so the horizontal I'm not going to cross either. So this one I'm going to go up, I'm going to approach. So that's that part of the graph. So now I'm going to plot negative 2, negative 2. So negative 2. And then I'm going to plot negative 1, negative 3. So there's that. So for that part of the graph, same thing. Vertical asymptote I can never cross. So it's going to come down like this. It's going to go through those two, and then what? Approach that. Flatten out. So there's the graph of that. There's two pieces. There's two portions to it. The left of the asymptote to the right of the asymptote. Okay? Yeah.
So what happened? There was an undefined, like undefined.
Say it again?
What happened if the negative 2 wasn't undefined?
Then you would just start plotting points and figure out what it's going to look like. Depends on what kind of a function it was.
So would you still have the like 2 parts divided?
Not if it's not a rational function. No. The reason why there's a break is because there's a discontinuity there. Alright, domain and range of this. So the domain is all the x's. So which x value can we not have? What x value does not exist? Negative 3. Right? Does my graph match that? So from left, it goes all the way out to negative infinity, and then it comes and does what? It gets, yeah, it's going to get really, really close to it, but never actually get to negative 3, right? And then on this side, it's going to get really close to negative 3, and then it's going to go to what? Infinity in the x. So here's how we write that. It goes from negative infinity to negative 3. But I don't want to include negative 3, so I put a parenthesis. Okay? Now, since there's another piece to this domain, what we do is we say in union with. We put a U there. Okay, union, together. then from what? And it starts on the other side of -3 and goes up to what? Infinity. So what that says is the domain is everything but -3. There's a break at -3. Okay? Now my range, my y values. So in this one, does this go down to -infinity? Comes up and then does what? It's close to but does not touch what? -4. And then it does what? Jumps up here, it gets really close to -4, and then goes up to what? Infinity. So the range is going to be what then? Four. What? Four. Okay, now, your domain is determined by your discontinuities. So the ones we're going to talk about are vertical asymptotes. Okay, range, sometimes horizontal asymptotes, depending upon what the function is. Okay, so look at your graph. Most of the ones we do are going to be based off your horizontal asymptote. Make sure you look at your graph. It goes up 2, gets really close to -4 on this side. Okay, it starts just above -4, goes up to infinity on that side. Okay, so that's the only break there. All right, next one. I want you to try it with your group. Go step by step, talking to each other, help each other. Step by step. Nobody work on your own. You should all be talking. All right, first let's do this. What do we got to do? Okay, and then we got to do what? Okay, so talk through it. All right, so where's our vertical asymptote at? 1. How do we find that? Yep, so at the bottom equal to 0. Where x minus 1 equals 0, positive 1.
Yeah.
Horizontal asymptote, where do I look for that?
+2.
Plus 2, the k on the outside, what I'm adding the outside. Okay, so I plot each of those, or I graph each of those. Okay, then I go to my table, put my vertical asymptote in the middle, so you should have had 1 in the middle, and then define. Okay, don't put a value there, there is no value. And to the left of that is 0, -1, to the right is 2, 3. So now when you plug them in, this is how you plug them into the calculator. So -1 is at 3.5. So -1, I'm at 3.5. At 0, I'm at 5. At 2, I'm at -1. And then at 3, I'm at 0.5. I'm going to sketch my graph following the asymptotes. So it's going to look like that. So what is our domain? What's the domain for this one?
-infinity to 1, comma 1, and then u, and then 1 to infinity.
Yep, what do we need? Brackets, parentheses, what? Parentheses on both. The parentheses show that the ones are not included.
Yeah.
Okay, our range is then what?
-infinity to 2, and then the u, and then 2 to infinity.
Infinity to 2, and then the union with 2 to infinity. Yeah. Parentheses on each of those also. Okay. Now, when it's in the next form, the only difference is how you find the horizontal asymptote. Okay? Everything else is the same. So if it's in the form of, now, careful, this A does not mean the same as the other A. They just put coefficients in there. A, B, C, and D are all coefficients. So if you have a linear divided by linear, something like that, then it's going to be, this is the only difference is finding your vertical or your horizontal asymptote. The vertical asymptote is the same, except the denominator equals to 0 and solve for x. So that's the same thing. Now the horizontal asymptote is a little different. Okay, because there are multiple x's. What you do is well, in this example, it's a divided by c. It's the leading coefficient of the numerator divided by the leading coefficient of the denominator. So the leading coefficient is the coefficient of the highest powered term. Okay? Now, just for future's sake, you do this when the degrees on top and bottom are the same. That's when you do this method. Okay? Which is what the form they give us. I just don't want us to start getting the habit of saying it's always this, always this. But when we get to the more complicated ones, instead of being just ax plus b over cx plus d, you could do like ax squared plus over bx squared. Okay? So you could have, as long as the degrees are the same, that's when we use this method. Okay? So it's the ratio of the leading coefficients is the horizontal asymptote. All right, and then the third step, you do the same thing. You take your vertical asymptote, put it in the middle, pick a couple points to the left, a couple points to the right, bottom. Everything else is the same. The only difference is how we find our horizontal asymptote. Everything else is the same. Okay? So that's the difference between the two forms. So, for this one, so how do we say we find the vertical asymptote? Set the denominator equal to what? 0 and solve. Well, how would I solve this? At 8, 4x, positive 8, then what? Divided by 4. So what's 8 divided by 4? So it's going to be at x equals 2 is my vertical asymptote. Set that in. So now, how do I find the horizontal asymptote? We got to look and make sure what form it's in. So since I have an x on top and an x on bottom, okay, I do the ratio of the leading coefficients. So what's the leading coefficient on top? Careful, the coefficient, just 2. The x is the variable. So coefficient is the number in front of the variable. So 2 over leading coefficient on the bottom is what? 4. Now that I'd probably reduce. What's 2 over 4? 1/2. 4.5 out. I don't care. Whatever you think of it. Okay, so draw my horizontal asymptote. There's my horizontal asymptote. Okay. Now we do the same thing with our table. That's the only difference in those two, how we find the horizontal asymptote. So now when I make my table, how do I know what values to put in the table? Horizontal? Then Q, not the vertical. Thanks, folks. Yeah, you gotta look at the vertical asymptote. You take the vertical asymptote, you put it smack dab in the middle of the table. Not necessarily in the middle of the function, but put it in the middle of the table. Okay, and then you make sure we notate that what? Because if you try plugging that in your calculator, you're going to get an error. Okay, and people are going to go, oh, I got an error when I did it. You're supposed to, because it doesn't exist. Okay? So write undefined there, so you know that I'm not even going to try and plug that in the calculator. So now I need to pick a couple points to the left and to the right of it. So to the left of 2 are what? 1 and 0. To the right of 2 are 3 and 4. Okay, now, when we plug these in, you have to be careful with these. Okay? Show you how you're gonna plug them in. The calculator. So, what you have to do, you have to use lots of parentheses in this one. Because there's more than one term on top and more than one term on bottom. So if I'm going to enter this in the calculator, if I want to plug in, let's say 0, here's how I'd have to do it. Parentheses, 2, parentheses, 0, parentheses, plus 3, parentheses. That's the top. Okay? Divided by the bottom, which there's more than one term, so I need parentheses. Parentheses, 4, parentheses, 0, minus 8, parentheses. Now, I guess you could have done this, parentheses 2, you could do times 0 if you wanted, plus 3, divided by parentheses 4, times 0, minus 8. You could do that also instead of using parentheses. That would work too. But remember when we plug it in, generally I use parentheses when I plug it in just to make things, okay? Better to use parentheses when you plug it in, especially if there's powers, and you don't think these things. Alright, so when I do that, I plug that in, it's going to be 3 over negative 8, which is negative 0.375. Okay, and then I'm going to go and do the same thing. So instead of having a 0 here, I'm going to have what? Yeah, you can go up, grab it, hit enter, to bring it down, and then just change the 0 to 1. Right? So it's going to be 5 over negative 4, which is negative 1.25. Alright, then I'm going to plug in 3. So 6 plus 3 is 9. That's 12 minus 8. So it'll be, let's see.
Oh, that one.
3, 6, 9, 12 minus 8, 4. So 9 fourths. Which is what? 2.35. Okay, then I plug in 4. The 8 plus 3 is 11. 16 minus 8, 8. It's 11 eighths. Which is 1.37. Okay? So now I plot those. So 0, negative 3.375. That's almost 3/4, or excuse me, 1/3. Right? 1/3 would be 0.3, repeating. About 1/3. Plug in 1 comma negative 1.25. So 1 negative 1.25. So 1 1/4. 2 is undefined. We got the vertical asymptote there for that. 3 is at 2.25. 2 1/4. And then 4 is at 1.375. So 1 and just over a third. So now when I go to sketch it, that. Okay. So, in this graph, what's my domain going to be? What do I need to exclude or disclude for my domain? Not for the domain. The 1/2 is the what? 2. Y value, right? I want the x value. So it's going to be, my domain is going to be from negative infinity to 2 in union with 2 to infinity. That's my domain. What's my range? The range is the y values. So it goes down to negative infinity, it goes up and approaches, but never touches what? 1/2, and it goes just the other side of 1/2 and goes up to infinity. So it's everything except for 1/2.
Mr. Steele, isn't 2 the vertical asymptote?
It is.
So what's in the
Why is it domain? Because the vertical asymptote goes this way. It's the x value that does not exist, right? It's an x value. Which one's your x's, your domain or your range? Domain. So if I plugged in 2 there, it wouldn't happen, right? 2 is the x value that does not exist. So I'm not going to include that in my domain because it doesn't exist. Okay? Alright? That makes sense? You know it's vertical, but it's still an x value, right? X equals 2. Okay, so everywhere along that, for that x value, it doesn't exist. There is no y. Okay, so x doesn't exist there. Alright, let's skip to the last ones here. Give an example of a rational function with domain, all real numbers, except, so for number 1, except 4. Or they give us the domain, or the domain is from negative infinity to 4 and union with 4 to infinity. So what would we have to have for the domain to not include 4? I want to write a function. Now, there's an infinite number of functions I could write, but they all have to have one commonality. Where do I get my domain restrictions from? Which one? So when do I know my vertical asymptote? How do I find that? Okay, what about it though? How do I find the vertical asymptote? So I use the vertical asymptote to stick to domain, but I found the vertical asymptote by doing what? Setting what equals 0? Denominator. So if x equals 4 is an exemption, we don't have it. So it would have had to come out of, this is the value it can't be. So what factor gives me x equals 4? So I'd have to have x minus 4 where? It's got to be a factor in the denominator. X minus 4 would have to be a factor in the denominator. So that would be the most basic one right there. Okay. Now, another one that actually would work, so you can plug in anything you want. Put a negative 1 up there, and then you could do 2x minus 8. Why does that one work? Yeah. Or you could factor it out, right? If I factor the 2 out, what factor is in my left with here? X minus 4, so x minus 4 is a factor. So just make sure you recognize that either one of these would work. As long as x minus 4 is a factor in the denominator. Okay? That means its domain would be exempt, or 4 would be exempt from this domain. Okay? So try number 2 right now, see if you can do number 2. Just give one. It doesn't say give an example. There's a whole bunch of options. number 2, what do they all have to have? You can have some different things, but they all have to have what? X plus 8 as a factor in the denominator. So it doesn't matter what you have in the numerator, as long as it's either linear or a constant. As long as you have x plus 8 in the bottom. Now, it doesn't matter if it's x plus 8, if you multiply by 3, so I'd have 3x plus 24, it doesn't matter any of those. As long as x plus 8 is the only linear factor in the bottom. So the simplest one would be this. Over x plus 8. But make sure you recognize that it could, like I said, we could have 3x plus 24. Why would that work? If you factor the 3 out, you're left with what? Let's say, or if you solve this, set the denominator equal to 0 and solve, what would you get? Subtract 24 divided by 3, you get what? Negative 8. Okay? So, as long as x plus 8 is a factor in the denominator, you're good. Alright?